Hello. So we're going to look at factoring still. Yes, we are still factoring. Okay, your job today is going to be to write down these problems as I go through them and then complete the remaining problems on your own for homework and submit that paper. So hopefully you've printed this document out, and if you haven't, now would be a great time for you to push pause on this video, get that document printed out, or get a piece of blank paper available if you didn't plan to print it, if you plan to do it on your own paper, which of course you can do, so that you're prepared to write this part, write down what I do. Great, let's go. Okay, so we're looking at number 2. Number 2 is a 3-term polynomial, and the coefficient of the squared term, k squared, is 1. And so therefore, this is a simpler factoring case. We simply need to find two values that will multiply to -40, but add to -3. We're always looking to multiply to the c value and add to the b value. And when I say c and b, I'm referencing from a quadratic that is in standard form like this, which clearly in number 2, instead of x, I'm using k, but the b value is -3 and the c value is -40. And again, that a is 1. Okay. So the two numbers that will multiply -40 but add to -3. Let's see. How about 8 and 5? You know, my brain first went to 4 and 10, but that's not going to get me anywhere, right? 8 and 5, I think we can make it work. 8 minus 5 is 3, but that would be a positive 3. How about if we did -8 plus 5? That would give us a -3. And then -8 plus 5 would give us a -40. Sorry, -8 times 5 would give us a -40 when we go to multiply. So these are going to be our two values that we can then take, and we write them as factors. K minus 8 times k plus 5. And that's it. This is factored. Yay! Okay, so now the next problem we're going to do is number 4. And number 4 is a problem where the first thing that stands out at me is, whoa, 5, 25, and 20, they all have a common factor. And if I simply can recognize this first and take that greatest common factor, the GCF, out from all 3 terms, then I've taken a complicated factoring problem and turned it into a simple factoring problem. So they all have that common factor of 5. I'm going to take that GCF of 5 out first, and that would leave me with 5 times the quantity x squared plus 5x plus 4. And now I'm just looking at factoring the trinomial that's inside the parentheses. So inside the parentheses, I have 3 terms, and the coefficient of x squared, my squared term, is 1. And so then therefore, I can look for 2 numbers that will multiply to c, which is 4, and add to the b, which is 5. And that would obviously be 4 times 1 gives us 4. 4 plus 1 gives us 5. And therefore, we can rewrite that trinomial as the product of its 2 factors, x plus 4x plus 1. And don't forget the 5 in the front. That's part of your final answer. Okay, and yes, you know, a question comes up. Do I always have to, what if I wrote my answer as 5x plus 20 times x plus 1? What if that was your answer? Well, let me tell you that this is correct, but it's not factored completely, because in this binomial right here, there still is that common factor of 5 that needs to be taken out. So take it out first. Sometimes you may not see it, and so then you end up factoring and you have to deal with those bigger numbers. You can still factor correctly, but you always look and check to make sure that there's nothing else that can be taken out before you move on. Okay. So then we're going to look at number 6. Number 6 is another trinomial, but this one is not, it's not it doesn't have a GCF, and because 3, 14, 15 has no common factors, and the coefficient of the squared term, m squared, is a 3, not a 1. So this is going to be our little bit more complicated factoring problem. That's okay, we can handle it. The first step is to multiply 3 times 15, and that becomes the number that we're looking for. 3 times 15 is 45. So we're looking then for two numbers that will multiply to 45, but still add to the b value, negative 14, down below. So when we look at 45, let's see, 45 is divisible by 5. 9 times 5. Oh, hey, I think we can make 9 and 5 work, because 9 plus 5 is 14. But I need to make that 14 negative. So if both of these are negative, negative times negative is positive. Negative plus negative stays negative. So from here, it would be so great if I could just write m minus 9, m minus 5, but that wouldn't be the correct factors. From here, what I need to do is I can go into rewriting the b term, negative 14m, as negative 9m minus 5m plus 15. So I just replaced 14m with negative 9m minus 5m. These are equivalent things still. I didn't do any like magic or weird stuff. I'm just replacing that middle term with two equivalent terms. So now I group the first two and I group the last two, and I look for GCF between them. And GCF in the first set, the first pair of parentheses, is a 3m. It leaves me with m minus 3. In the next set, because that negative 5m, that first term there in the parentheses is negative, then I'm going to take a negative 5, which gives me inside my parentheses a positive m and a negative 3. How do I know that's right? How did that? Well, think about it. If I were to distribute this negative 5 back into the parentheses, would I get back to what I had? Negative 5n plus 15. Yes. So therefore, I know that that's right. Now, since my binomials here match, then that's the final step. I factored that as a common factor from both terms. M minus 3 times 3m minus 5. So these are the two factors that when multiplied together will give me that original trinomial. And again, look at, when I think about my two numbers that I found here, my final answer didn't have those in them, right? So this is something that you need to really recognize and understand. Okay, the next problem, number 8. Wait, I think I want to do, no, I'm going to do number 9. Number 9. That's right. Number 9. I'm doing number 9 because guess what? It's a little trickier than number 8, but that's okay. I like to do the harder ones and let you guys figure out how to handle the easiers. Number 9 is 2 terms. This is different. It's not a trinomial. It's 2 terms. So is there a GCF? 25 and 4? No. But is this a difference of squares? Yes, 25x squared is a perfect square, 4 is a perfect square, and it's a difference. So this means that I can factor this thing using my difference of squares format, which says I'm going to put the factors of each, the first term and the second term, in the first and second spots of my binomial. So like 5x squared is, 25x squared is really 5x times 5x. And so that means I would take a 5x and put it at the front of each binomial. 4 is 2 times 2, right? So that means I take a 2 and I put it at the front of each, not at the front, at the back of each binomial. And then here's how you handle the signs. One's positive, one's negative. And that's it. We're done. The terms inside the binomials are exactly the same. The difference is that one has a positive sign and one has a negative sign. Okay, number 11. Number 11 is a trinomial, and there's no GCF, so bummer. But before I just start diving into finding two numbers that multiply 25, add a negative 10, this is special because 25x squared is a perfect square. It's 5x and 5x. And 1 is also a perfect square. Yeah, 1's perfect square, don't forget. Well, when you have a trinomial whose first term, the ax squared, and the last term, the c, are both perfect squares, when that middle term, b, equals 2 of those factors multiplied together, then it's what's called a perfect square trinomial. So if I take one of each of these factors, 5x times 1, and I double it, I say 2 times 5x times 1, that would be 10x, right? Yes. That means 10x here, 10x here. That means that this is a perfect square trinomial. And that means that this will factor to two binomials that are exactly the same. So this is what's called a perfect square trinomial. And it will factor to two binomials that are exactly the same. And just like the difference of squares up above, we take the first term and we split it and we put it in the front of the binomials. We take the last term, we split it, we put it at the back of the binomials. But what do I do about the signs? Well, the signs is whatever that sign of the middle term is right here. If it's negative in there, then it's negative down here. They're both negative. They're the same. I could alternately rewrite this as 5x minus 1 quantity squared. Either of these are the answers. Look on your paper. Do you see another problem that's a perfect square trinomial? Hint, hint. Yes, it is. Okay. Finding products. You know, a product is multiply, right? So this is asking you to multiply. If you're multiplying two binomials, you're basically doing like double distribution. You're distributing the 2x to the x minus 4, and you're distributing the 1 to the x minus 4. We've talked about this. 2x times x is 2x squared. 2x times negative 4 is negative 8x. 1 times x is x. And 1 times negative 4 is negative 4. And you simply combine your like terms in the middle, and you have 2x squared minus 7x, negative 8 plus 1 is negative 7, minus 4. And this is now the standard form, or that's the product of those two binomials multiplied together. If I was going to do number 13, since this is a 2 by 3, I could use the box if I'd like. Remember, we talked about the box. You can go 2 rows, 3 columns if you want. You make the multiplication table. Or you can just start distributing. That one, 3r's got to go to 5r squared, 2r, negative 6. And then distribute 6 to the 5r squared, 2r, and negative 6. And collect up all your like terms. Okay. Let's move on to the last couple problems down here. GCF, right? Factoring out that GCF. I'm going to look at number 16. Sorry, I take it back. Ha ha ha. We're going to look at number 15. This one right here. So there's two terms here. I'm looking for a GCF. Greatest common factor. 6 and 7 have no other common factors besides 1s, and that doesn't really count as a bigger common factor. But now I got to move on to the variable parts. The first term has 5 m's, and the second term has 3 m's. So when I look for the greatest common factor, the most common factors, I have to look for the most m's that they have in common. If one has 5 m's and the other one has 3 m's, then the most that they have in common is 3 m's. So that becomes part of my GCF, m cubed. Now I need to move on to the n's. The first term has 4 n's, and the second term has 2 n's. And so the most n's, the greatest amount of n's that they have in common is 2n. Or, I'm sorry, not 2n. It's 2 n's, or n squared. So m cubed times n squared becomes my GCF. And my job is to factor that out and then write this polynomial as a product of the GCF and the two terms that would get me back to the original 6m to the 5th n 4th plus 7m cubed n squared. Well, this m cubed n squared, in order to get me back to 6m to the 5th n to the 4th, I'm saying, what would I have to multiply it by? I would have to multiply it by 6, the 6 isn't even, it definitely needs a 6. I'm also missing a certain amount of m's, right? I have 3 m's in my GCF, but I have to multiply m cubed times m squared to get me 5 m's. So I need an m squared. And then I need to multiply that n squared by another n squared to get me the 4 n's that are in my original. Okay, moving on to the next term. What would I have to multiply my GCF m cubed n squared by in order to get back to my original? Definitely I have to multiply by 7. And then I have an m cubed and there's already m cubed there. I have n squared, there's already n squared there. So it looks like that's it. Now, how do I know that I'm right? How can I be sure that I'm right? Well, multiply these two things back together, meaning distribute m cubed n squared into the parentheses and see if you get back to the original. If you do, then you're right. Okay, that's it. That is my lesson for today. And your job will be to finish the remaining problems on this paper and turn it in. And also, please be prepared to join us for the Zoom meeting on Thursday. I'm going to talk to you about how we're going to work our Chapter 9 assessment, because we have to do something about it. We can't just do nothing. And you guys have been working hard to learn how to factor, and so it's come time now to where we look at taking a test on that and what that's going to look like with this distance learning stuff. So, okay, you guys, I'll see you all Thursday. Bye bye.